And here we are, net ionic equations.
We're back.
Yep, time for chemistry.
Yep.
We better get busy.
Work with numbers and
I
balancing
don't want to
equation.
push that yet. Let's look at types of chemical equations.
Okay.
All right. So first we have three types of equations. They're pretty simple.
Molecular, complete ionic, and net ionic.
Exactly. So
Yeah.
let me show you what we mean by
Molecular.
molecular.
All right.
Okay, that means we write everything together as if that's how they are,
Yeah.
just hanging out as a compound in
Mhm.
one molecule, right? So
Yes.
cadmium nitrate, we don't separate it,
Mm-hmm.
even though we know we can.
Yeah.
We don't
But
separate
we're talking molecular equation.
them. Right. So we balance this
Mhm.
molecular equation just like we normally would.
Yes.
Now a complete ionic equation, if we're using the same reaction,
Mm-hmm.
we would take anything that is aqueous and break it apart
Break it apart.
into the ions it was formed from.
What about solid?
Solid does not exist as ions.
Yes.
So they stay together.
Yes.
So
Okay.
we already wrote these ions in our last podcast.
Yes.
So cadmium was a 2+.
2+.
And how many nitrates do we have here?
We have 2 nitrate.
Okay, so I have to put the 2 in
Mhm.
front, up here,
Oh, do not forget that.
right? And then I have sodium
2,
sulfide,
mhm.
2 sodiums.
2
good.
sodiums and a plus.
Okay, and then sulfur.
I have 1 S minus.
So 2 minus.
It's 2 minus because
Yeah.
of the okay. The
Right.
crisscross thing.
Right. Now with cadmium sulfide, when we did our solubility rules, we learned sulfide is usually insoluble
Yeah, so
unless it's with an alkali metal. But
Yes.
cadmium is not an alkali metal.
it's a solid.
Yeah.
So it does not dissolve in water,
Right.
right?
Yep. Now I'm running out of space. I'm just going to write this down here, okay?
Mhm.
So 2 sodium nitrates means 2 sodiums
Mm-hmm.
and 2
And-
nitrates. Because I have 2 of this,
Yeah.
right?
Mhm.
So I have 2 of the sodiums and I have 2 of the nitrates. So remember to keep everything balanced.
Yeah.
All right, now that is called a complete
Complete
ionic equation. Because every ion that's in the solution is
With
listed
separate
separately.
thing. Yep.
Okay, let's look at net ionic equations.
Okay.
So here's the complete ionic equation that we just
Mhm.
wrote. Net means what is left when we cancel out all the terms that appear on both sides that are exactly the same. So look, cadmium started as a 2+,
Mm-hmm.
and now it's in a solid. So that's not the same.
We can't cancel them.
No.
No.
But nitrate, NO3,
Mm-hmm.
is the same on both sides, NO3.
Okay. So
So we're
out.
going to cross this out. Those cancel each other out. Because really what happened to nitrate in the reaction is not a darn thing.
Yeah.
Nothing changed.
Yeah.
So nitrate didn't actually react.
So what do we call them?
Those are spectators.
Spectators. I remember that. Spectators.
Yes. That's a spectator ion.
Ions.
Oh, I don't need my plural there.
Spectator
I need it there.
ions.
Okay, now let's see. Sodium
2 Na plus.
and 2 Na+. That's a
Ooh.
goner.
Yep.
Okay, how about sulfide? Here became cadmium sulfide. Yeah,
no.
it's not the same. We can't.
Yeah.
So let me write what's
The
remaining.
net ionic equation.
Like in your net paycheck after they take out your taxes
Yeah.
and your insurance.
Oh,
That's the net pay.
okay.
It's so much smaller than what the paycheck says.
Oh.
I know. Just like
And
our-
it's true in equation,
yes,
this way.
that ionic equation is so much smaller than the complete ionic
After
equation.
we removed everything.
Right,
Yeah.
because truly in the beaker, the reaction that takes place is this reaction.
Mm.
Because what happened to sodium? Nothing. And what
Yeah.
happened to nitrate? Nothing.
Nothing.
And that's why we call them spectators. They didn't get involved
Yeah.
in the
In
reaction.
the reaction.
So let's talk about basketball. Not involved.
Oh, if you're a basketball player, you don't want to become a spectator, right?
No.
You want to play.
Right. And can you imagine somebody's mom coming out onto the court to sock someone because she elbowed her son?
Yeah.
Yeah, I could see that happening for some of my kids. But she'd probably get arrested.
Oh,
because
yeah.
spectators are not supposed to get involved.
Exactly.
Right? You're not
No.
supposed to get out and play.
Yes.
That would be amazing, though. Like if a spectator came out of the stands and dunked on someone. Boom! But that's not what happens.
Yeah, that's not gonna happen.
No. I'm giggling to myself thinking of some of the mamas I know. All right, so equations, any equation has
Must
to
be
be balanced.
Yep.
Even net ionic equations.
Exactly.
So the materials have to balance. By this we mean the number of atoms have to be the same on both sides. So balance your equations first, and then you can start breaking them apart.
Yes.
It's easier that way, I promise. Another thing that has to work is electrons. Right. Electrons are also made of matter, right?
Mm-hmm.
They have to balance.
Yes.
So the charge has to be the same on both sides. All right, well, let me show you what I mean.
All right.
Okay. So if we have sodium hydroxide and magnesium chloride mixed, what are we going to make? This looks like a double replacement reaction, a compound and a compound reacting together.
Yes.
So I'm going to
So
go
one
ahead
will
and
replace the other one.
So I have NaOH, that's aqueous.
All right.
MgCl2.
Cl2, also aqueous.
All right. And it makes some precipitate. So in double
Na.
replacement, we trade places with these two.
Yeah.
They switch spots.
So I bet that's MgOH.
Right. Except magnesium hydroxide have to crisscross the charges.
Yes, crisscross the charges.
And then NaCl. Ooh, I barely squished that one in.
Ooh.
Yep. So this is solid. Remember hydroxide solubility rules? And I need another color. This is aqueous because I can't write black on black. Okay. So now what do? Break apart anything that's aqueous.
Yes.
Right?
They're balanced already. No.
Oh, no.
Are they? No.
Good
Na.
catch. So I need 2 sodium hydroxides. Now are we balanced? Not quite. 2 sodium chlorides.
2 Na, 2 Na. 2 OH, 2 OH in there. 1 Mg, 1 Mg, 2 Cl. Yes.
All right.
Balanced.
We got it balanced.
Yep.
So now let's break it apart. Sodium hydroxide will break into 2 sodiums, and don't forget 2 hydroxides.
Yes.
Because the 2 means both of these.
Both of these. Yeah, both of those will do.
Okay, now magnesium chloride.
Mg.
How many magnesiums?
2 plus. No, 1 only.
There's 1 of them.
But 2 plus, yeah.
Okay.
All right.
And how many chlorides?
2.
2.
Yeah.
Remember, on your naming card, there is no such thing as this.
Yeah.
That 2 has to come out front.
Yeah.
Right? It can't be back here.
All right.
Okay. Next, magnesium hydroxide
I have
is solid.
1.
We have to leave it together.
Yeah.
Okay. Changing colors so we can see my writing. Sodium, there's 2 sodiums.
2 sodiums.
And 2 chlorines.
Yep.
Squish my charge in. We got it.
Yep.
Do you see anything that is the same on both sides?
Yes, I see 2 Na plus.
All right, we'll cross that out.
And I see 2 Cl minus.
Okay. But what about this hydroxide, OH?
2 OH. No.
That's not the same.
No, they're not the same.
Okay. So the net equation
Yeah.
means we write down what's left.
2 OH minus plus Mg2 plus yield MgOH.
Okay. Why do you suppose I wrote 2 hydroxides with magnesium? When I wrote this product, MgOH,
Yeah.
I put 2 OHs.
It's because there's 2.
Yeah, because of the charge.
Yeah.
Hydroxide is a
Yeah.
-1. Magnesium is a 2 plus.
Yes.
So,
crisscross that thing.
yeah, I need to have 2 hydroxides
Yeah.
to make this work.
Exactly.
So let's check our balancing.
All right.
If I have 2 hydroxides, that means I have 2 negatives.
Mm-hmm.
And I have 1 magnesium, that's a 2
2
positive.
positive.
They add up to 0.
Yeah.
Over here, do we have any charge? I have 0.
Mm-hmm.
Better add up to the same number on both sides.
Okay.
Okay, so
All right.
we're good with example 1.
Okay.
Let's do another one. We have a lot of examples because at first this seems tricky,
Yeah.
but we'll work
But
it through.
if they're going to keep on watching, and especially if they're going to rewind and then watch it again,
Yes.
I bet they're
And
going
you
to get it.
practice, do your
Yeah.
homework.
And follow along with us.
Right.
That's very important.
Okay,
Okay.
I need the charge of copper that's with sulfate.
All right.
So I know sulfate is a 2 minus.
Yeah.
So which kind of copper do we have here? Copper 1 or copper 2?
I think it's copper 2. No, copper 1. No?
It's got to be copper 2.
Yeah, because there's
Because there's only one copper with the
Yeah.
sulfate, so it has to be copper
Copper
too.
2.
Okay, how about barium chloride? Barium's always the same charge.
Yeah.
So that's easy.
2 plus.
And then chloride is always a minus 1.
Minus 1.
There's 2 of them.
Yeah.
So I'm going to put that out front.
Okay.
Okay. Why do you suppose we don't break this into S and O?
Because that's a polyatomic ion.
Right. Yeah.
Yeah.
It's
in
a
your
family.
card.
Don't
Yeah.
break up my family.
Yeah.
Yeah. Okay. Copper. Oh, this was copper too, right?
Yes. Copper 2.
Silver, mercury, and lead are soluble. Copper isn't one of the 3 amines.
Yeah. Cl. 2 Cl minus.
Okay. And then
And then
barium
barium.
is always a. Oh, look. Solid.
It's a solid now.
So I don't have to break that one up.
Yeah.
Squishing my letters in. Okay, so there's our complete ionic.
Mm-hmm.
Let's look for something that
I see Cu2
is
plus.
the same. Yeah, that's the same on both sides. So that's a gunner.
I see 2 Cl minus.
Okay. And I think we're left
Yeah.
with this reaction.
Okay. SO4
Mm-hmm.
2 minus plus Ba2 plus.
Okay, barium sulfate.
Barium
Well, that makes sense, right? If we put sulfate together with barium, we make barium sulfate.
Mm-hmm.
It should make sense. You should get something that works.
Yes.
Yeah. If you don't, you're doing it wrong.
Is it balanced? 2 minus 2 plus? Yep.
Yep, everything's balanced.
All right.
We're on to example 3 now.
Yay.
Oh, but we have to do extra work.
Oh yeah, we need
Yeah.
to predict what is the
The spectator.
Yeah.
Because we have iron hydroxide identified.
That's
but
easy.
What is left? Let's see. If lithium and iron trade partners,
Yeah, so that's Li.
then we get iron hydroxide and lithium
lithium.
nitrate.
Yeah.
Okay, let's check our charges. Lithium is +1.
Plus 1.
Nitrate is -1. So that one was
Oh
easy.
yeah.
Oh, I like it when it's easy.
Yeah.
Okay, so this is not a balanced equation yet.
Okay, so we
Because
have
I have 3 nitrates here
mm-hmm.
and only 1 here. So I'm going to put a 3
3.
in front. And that changed lithium.
So put 3 in front of lithium.
Okay, that changed hydroxide. So come over here.
All right.
Oh, it's
so
already 3.
It's
hydroxide.
already 3, yeah.
Okay,
Fe,
so now it's balanced.
yeah. Fe is also balanced.
Good.
There we go.
Okay, so now we'll break apart anything that's aqueous. And this looks like the
Fe,
ferric ion,
Yeah, 3 plus.
not ferrous.
Yes.
Because there's 3 of them with nitrate.
Yeah.
Or 3 nitrates, I mean.
Mm-hmm.
Undoing the
NO3.
crisscross. Oh,
Minus.
3 of these. Ooh, I almost messed up.
Yeah.
Okay, 3
3
lithiums,
Li. But that's plus.
right?
And
And
3 OH.
3 OHs, because the 3 means everything in here.
Yes.
All right.
And
I have to learn to write smaller and complete ionics.
yeah.
Okay, so 3
3
lithiums,
lithium. And 3 NO.
right? 3 nitrates.
Yeah.
And 1 molecule of iron hydroxide.
Because it's a solid. Don't
Yes.
break them apart.
Yeah.
Yeah.
Okay. So what's the
Ooh.
same?
I see 3 Li plus.
All right.
And then 3 nitrate.
Nitrate.
And that's it.
That's it. So we've gotten rid of our spectator ions.
Yeah.
Oh, I have them right here. Spectator ions.
Mm-hmm.
We don't
Oh!
we don't get to write them on our roster because they're not playing in the game.
So that's Fe3 plus.
Fe3 plus 3 OH,
3 OH
minus,
minus.
3 hydroxides.
Mm-hmm.
We made iron 3 hydroxide.
And it's
There we go.
balanced. I see 3 plus and 3 minus.
Good.
Yeah.
Then everything's balanced. Even the atoms are
Yes.
balanced.
That's
Perfect.
net ionic equation.
Okay. Let's make it a little harder.
Ooh.
This time, we need to predict the solubility.
Yeah. Are we going to put S or AQ, right?
S
Are we going to
means
do
solid,
Solid.
and AQ means soluble.
Soluble.
Don't mix those up. Okay, so does anybody want to hang out with sodium?
Nah.
Nah, so we put AQ because he doesn't make precipitates with
Yes.
anybody. How about calcium?
Calcium.
We don't have a calcium rule. We have a chlorine rule.
Yeah.
Remember, knuckle, no so.
Knuckle, no so.
So chlorine is the 3 amigos,
Yep.
silver, mercury, and lead.
And Ca is not one of them.
All right, so that's AQ.
Yep.
Now I don't know what goes here, but let's figure it out.
Yeah.
If I have NaCl Nah,
Mm-mm.
not a precipitate. So
I
this
bet
must
that's
be
a
solid.
solid.
Must
Okay.
be. Let's see if we get something solid.
All right.
So switch partners. These guys switch places.
So I should
So
write
calcium is going to take the partner of sodium.
Yeah.
So I get calcium with phosphate.
Mm.
But be super careful. Calcium is a 2+.
Yeah.
Phosphate is a 3-.
3-.
So if I crisscross the charge, I need
Ca3.
3 of these. And there's already a number here, Mrs. Uy. How do I show 2 phosphates?
Oh, enclosing.
Okay,
Yeah.
no big deal. Don't panic.
Yeah.
Use parentheses.
Yeah. Do not multiply them.
Right.
You know that some of my students
They want to call
multiply
it PO8
Yeah, they multiply it.
or they add PO6.
Sometimes they add.
Yeah.
Yeah.
That's
No.
not. Just put parentheses around
Yes.
it. Okay, let's break them apart now. I
Oh, we're breaking them.
No, we have to balance.
Okay, Na. I have Na.
Okay, I need 3 NAs, right?
Yeah, because there's 3.
Okay, that's not going to work though, because chlorine is 2. So I can't have this. What's a multiple of 3 and 2?
6.
6 should work. Okay, let's try a 6 here. So if I have 6
Ooh.
NAs, let's put a 2 here.
2 times 3, that's 6.
Okay, and a 3 here for my chlorine.
3 Ca. I have 3 Ca on the other side. I have 6 Cl. 6 Cl.
How about phosphate?
Phosphate.
2 here, 2 here. I think we're good.
Yeah.
Wow, I'm just randomly drawing. Sorry, I don't know what happened.
Okay.
Okay, we're breaking this apart into ions
All
now.
right. So I have 2 Na.
2 Na. Okay, and 2 phosphates also. The 2 means both of those.
Yes.
Okay, how many calciums?
3.
3. Okay, 3.
And I have 3 Cl.
Oh, no, I don't. Look,
No,
Cl2.
6.
Yeah.
6. 3 times
Tricky,
2 is
look,
6.
I let that happen
know.
here too. 6.
Oh, gosh.
Wow, everybody makes mistakes.
Oh.
Sometimes we have to teach you how to make mistakes.
Yeah.
It's okay.
Because you learn out of from your mistake.
Yes.
Hopefully.
Right. Anyone who didn't make mistakes, I wouldn't want to be around them very much.
Okay.
Okay, calcium is a 2+.
Yeah.
Oh, but look,
It's
solid.
3.
Solid.
Oh, no, yeah, we are not
We
going
leave
to
it
break
together.
Yeah.
So calcium phosphate stays together.
Yeah.
And then 6 sodium chlorides. So 6
Na
sodiums.
plus.
And my scribbles.
And
And 6 chlorides.
Chlorides.
Okay.
There you go.
Do we have spectators?
Yes, I see 6 Na plus.
6 Na+. Okay,
And
gone.
6 Cl minus.
Gone.
And that's it.
All right, those are the spectators.
Yeah.
So we have what's left in the net ionic equation. 2 phosphates, 3 calciums,
Yeah.
and that makes 1 calcium phosphate. So let's check our charges. Okay, because this one's kind of hard.
Yeah.
2 times 3 gives us a 6 minus.
Minus. 3 times 2, that's 2. 6 plus.
Oh, okay. And that adds
Oh.
up to 0.
Yeah.
Perfect.
Perfect.
We're rolling now. Example 5.
All right.
Oh, we have to do.
When we get to example 5, they're going to master this one.
I
this
think
way.
so.
Yeah.
So now we're going to do solubility and double replacement
All
product.
right.
So I'm trading places, trading ions with silver and sodium.
Yeah.
So silver gets to partner with sulfur now.
Yeah.
There's my silver sulfide. And sodium will partner with all this mess. C2H3.
Acetate? Is that
You got it, acetate.
acetate?
Right.
Yeah.
So sodium acetate is NaC2H3O2.
O2.
Acetate is a
Acetate.
big particle, but don't let that trick you.
Yeah.
Yeah, it's on your ion card.
Yes.
Use it. Okay, let's do solubility.
All right.
Anybody want to hang out with sodium?
Nah.
Nah, he's aqueous.
Aqueous.
No precipitates for him. Now, silver is one of our 3 amigos.
Yeah.
But remember the nose, the close, and the chose?
Oh, yeah.
Here's my cho.
Cho.
That's aqueous.
aqueous.
And so here it is again,
Oh.
aqueous,
Nah.
right?
I
And
bet
then
that's
S,
S.
sulfide. If we didn't have something that precipitates, we would have no reaction.
Yeah.
And in this case, sulfide is almost always insoluble.
Yes.
Unless he's with an alkali metal, and silver is definitely not an alkali metal.
Yeah.
Okay, we're breaking apart stuff that's aqueous. Wait, we balance.
So you have 2 Na.
Let's look to balance first.
Okay. Let's see. 2 Na.
2 Na.
Two.
Okay, so now I have 2 acetates. Let's come and make 2 acetates.
2 acetates.
And that
Now I
made
have
2
two
silver.
Yeah, I have 2
Oh,
silver in there.
Okay, so
We're
we're
good.
balanced.
Okay. That's easy.
Yeah, always balance first, right? Balance. Because if you try to cancel your spectators and it's not balanced, it's a mess.
Okay.
All right, so 2 sodiums. That's not a good sign. 2 sodiums.
Plus.
And 1 sulfide. Okay, silver acetate was soluble.
Yeah.
So 2 silvers.
2 silvers.
And 2 acetates.
Yeah.
You want to know how I know that silver is a +1? Because it's on my naming card.
Yeah.
That's how I know.
It's a lifesaver naming card,
It
guys.
sure is. Okay, sodium acetate, that's soluble. Let's
So
break
2
that
Na
apart.
plus
And how many acetates?
2.
Right.
Yeah.
Okay, and how about silver sulfide?
No, it's a solid.
So leave it together.
Yes.
All right. So now, spectators. What could we cross out? Who's on the same on both
I see
sides?
2 Na plus.
Okay,
And I see 2 acetates.
right. So those go away, and we are left with sulfide
Sulfide.
combining with silver.
Mm-hmm.
Oh, there's 2 of them.
Yeah.
Oh, I almost messed that up. And we made silver sulfide. That makes sense. Are the atoms balanced?
Yes.
And the charges look balanced?
Yes.
So we're good.
Yeah, we're good. 2 minus 2
This is getting
plus.
easier.
Oh, yeah.
I think so. Oh dear.
Oh, my.
You suppose we could do this one still? Aluminum plus H2SO4.
Is there something missing in there? No.
Ooh, no, this one's going to be hard though.
Okay.
That would be, suppose that you took aluminum foil and you put it in sulfuric acid.
Didn't we do that? It's not sulfuric acid, right?
We put it in copper chloride.
Okay.
Yeah. There's the bell. Time to go home. Bye now. All right, so if we have aluminum foil and sulfuric acid, this is a single replacement reaction,
Yeah.
not double replacement.
Not double replacement.
Let's see if we can still do a net ionic equation.
All right.
Okay.
Let's try.
So first, aluminum is going to steal the partner from hydrogen.
Yeah.
Okay. Now I've got to watch my charge.
Yeah.
Aluminum is a 3+.
3 plus.
Sulfate is a 2-.
Look at your naming card.
Right, crisscross.
So Al2,
Mm-hmm.
SO4, in closing parenthesis 3.
Okay.
And
Now,
then
what
we're left
happens
with-
to hydrogen? Hydrogen by himself is H2. It's diatomic,
diatomic.
right? And hydrogen is a gas. So that bubbles out.
Yeah.
Let's look at our solubility rules though for aluminum. Aluminum is, we don't have a rule for that.
Yeah.
We have a rule for sulfate.
Sulfate.
Knuckle no so.
Yep.
So,
So,
all right. Anything that's an exception will be solid.
Yeah.
Silver, mercury, lead.
and Al is not one of them.
No,
So it's
barium, strontium, calcium. So this is
it's
aqueous.
Aqueous.
All right. So a gas we can't break apart,
No.
but aqueous we can break
We
apart.
can,
Anything that's aqueous. So let's balance first.
So we have 2
Two.
Al.
And 3 and 3. How's that look?
Yes. 3 times 2 is 6. 3 times 2 is 6. That looks fine.
Okay. So now 2 aluminums
And
is
3
solid.
plus-
I can't make it ions.
Oh,
or anything,
yeah.
Right?
Yeah.
Okay. Now sulfuric acid is going to be
3H.
6H.
Oh, yeah.
Oh,
3
right.
times 2 is 6.
Yeah.
All
Yeah.
right.
And there is no such ion on your card as this. You
Exactly.
can't write it that way.
Yeah.
Okay, how about sulfate?
That's
SO4.
SO4.
2 minus.
2 minus.
And how many of those? 3, right? Okay. So should we break this one apart?
Yes, because that's aqueous.
Aqueous. All right, 2 aluminums. That's a plus charge.
And
And then three
3
sulfates.
sulfates. 2 minus.
Okay.
Plus.
And 3 hydrogen molecules.
Yeah, we can't break apart gas, right?
Right, leave it as it is.
Yeah.
Okay, do you see any spectators?
I see 2 Al.
2Al. Oh, that's not the same. It got a charge.
Oh, yeah.
That's not the same. Anything
Oh.
else? Hydrogen
3.
is plus. Not a plus anymore.
Not a plus anymore.
Sulfate?
Sulfate only.
That's the same on both sides. So that's our only spectator.
Yeah.
So this is a net ionic equation that looks weird because we start with aluminum, we add hydrogen ions to it,
Yeah.
and guess what? Aluminum is going to give its electrons to hydrogen. So aluminum becomes positively charged,
Yeah.
and the hydrogen becomes zero charge.
Yeah.
All right, let's look at the charges again.
Okay, so you have
Oh, I messed the charges up. Aluminum's a 3 plus.
3 plus.
Okay. So now, looking at charge, I have this is 0, and then this is 6 positives. Now on the other side, I have 2 aluminums. Each aluminum is a 3 plus.
So 6 plus?
6 plus altogether. And then any element is a 0. Hydrogen is 0. So our charges are the same on both sides.
Yes.
So it looks funny because there's no negatives, but this is our net ionic equation. The sulfate is just a spectator.
Yeah.
What really happened here is that aluminum gave electrons to hydrogen. So remember, Leo says, Gur, which of these substances lost electrons? Aluminum, right?
Aluminum, yeah.
So aluminum is the part that is being oxidized.
Yeah.
And hydrogen is the part that's being reduced.
Yep.
So we talked about redox reactions.
Redox reaction.
This is what it looks like when we have the net ionic equation for a redox reaction. Leo says Gur.
All right.
Or you could remember oil rig.
Oil rig.
Yeah. But that's podcast 7.2b. So they've already seen about
All right.
Leo and Gur.
Okay.
All right. I think that's it.
That's it.
I don't know. Let's see. Is that done?
I think so.
Always been. We had another example.
We have another example.
We're skipping it.
Okay.
So that's it.
All right.
We're all done. So
And we're going to do practice in class.
We always
Practice
in class.
makes perfect.
That's right.
Is that true?